Now I'll explain the product of two vectors. Let us consider two vectors, say A and B. So we have two types of product. The one is called dot product and another one is called cross product. Dot product you can also call it as a scalar product. Cross product you can also call it as a vector product. So first I will explain dot product. So with the two vectors of A and B, dot product is denoted as A dot B and is given by magnitude of A, magnitude of B into cos theta. Whereas cross product A cross B is equal to magnitude of A, magnitude of B into sin theta into n cap. So here n cap is another vector which is perpendicular to both A and B. So just I will explain dot product and cross product with the basic unit vectors I and j. So what happens I, dot product of I and I. So if I substitute in this formula, magnitude of I is 1, magnitude of I again is 1 and cos theta, theta is the angle between I and I. We know I cap is a unit vector along x-axis. So angle between x-axis nothing but I and I is 0. If I substitute here, cos 0 is 1. So the answer of I dot I is equal to 1. Similarly, if I take j dot j as well as k dot k, that is equal to 1 only. Means dot product of like vector is 1. Whereas what is the dot product of unlike vectors I and j? If I substitute in this formula, magnitude of I is 1, magnitude of j is 1, but angle between I and j is 90 degree. So cos 90 is 0. So I dot j is 0 as well as I dot k is 0 and j dot k is 0. That is dot product of unlike vector is 0, dot product of like vector is 1. So what happens in the case of cross product? First I write a general formula. Vector A cross vector B is equal to magnitude of A, magnitude of B sin theta into n cap. So if I take I cross J, unlike vectors, cross product of unlike vectors. Before that, okay, I will explain cross product of like vector. What happens I cross I? I cross I again if you substitute here, magnitude of I is 1, magnitude of I is 1, angle between I and I is 0. If I put 0 here, sin 0 is 0. Nothing but cross product of like vector is 0. Similarly, j cross j as well as k cross k is 0. So what happens cross product of unlike vectors? So here instead of I cross I, now I will take I cross j. So I cross j is equal to what? According to this formula, magnitude of I is 1, magnitude of j is 1. Angle between I and j is 90. If I substitute here, sin 90, you will get 1. So this is 1 into 1 into 1 and one more extra term is there. That is another vector which is perpendicular to both the vectors, nothing but which is the vector which is perpendicular to I and j is nothing but it is k. So cross product of unlike vector is k, means I cross j is k, it is not fixed. So I can write easily with the cyclic form. If I write I j k, so cross product of I into j is k, cross product of j k is I as well as cross product of k and I is equal to j. Just observe student, I cross j is equal to k, j cross k is equal to I, k cross I is equal to j. It is in cyclic order, I, j, j, k and k with I. So if you interchange, same answer means I cross j, if you interchange to j cross I, plus k become minus k. Similarly, this is also negative. So in the case of cross product, it is not commutative. We can't interchange as it is. But in the case of dot product, either you write I dot j or j dot I, you will get the same answer. Now I'll explain this dot product and cross product with one example. You will take one simple problem. Let A equals I cap plus 2j cap plus 3k cap, and another vector B equals 2i cap minus j cap minus 2k cap. Now what happens? Dot product of these two vectors A dot B. I'll calculate both dot product as well as cross product with this example. A dot B, just substitute I cap plus 2j cap plus 3k cap dot vector B 2i cap minus j cap minus 2k cap. So as I explained, dot product of like vectors gives 1, but whereas dot product of unlike vectors, nothing but I dot j as well as I dot k becomes 0. Means with a usual multiplication, no need to multiply first term with all three. Just you have to multiply I with I as well as j with j as well as k with k. So according to that, what happens the formula? It is the solution 1 into 2, that is 2, and I dot I become 1. Plus into minus, minus. So 2 into 1, that is 2. So j dot j become 1. Plus into minus, minus. 3 into 2, 6. So A dot B is equal to, the answer is 2 minus 2. Cancel, you will get minus 6. Just observe here, dot product of two vectors become a scalar. Means here I dot I become 1, j dot j 1, and k dot k become 1. So final answer, always in the dot product you will get scalar only, no I j k comes. Whereas in a cross product, how to calculate cross product of two vectors? Same example I will explain. Consider A cross B. So this one we can't solve in the usual method. We will go for determinant rule. So determinant, write in the first row I, j, k, and in the second row component of first vector, that is I cap coefficient is 1, then 2, then coefficient of k is 3. Cross B, in third row component of second vector, that is coefficient of I 2, coefficient of j is minus 1, coefficient of k is minus 2. So this is the formula to calculate cross product of two vectors, formula as well as a procedure. Now how to solve this 3 cross 3 determinant, that you know, this is plus, this is minus, and plus. Now this is equal to I cap into plus I cap into, leave the particular column and particular row, you will get these 4 elements. Determinant of 4 elements A, B, C, D, that is 2 cross 2 is equal to how? A into D minus B into C, or C into B, that is BC. So this is the same way you calculate here. Determinant of this 2 cross 2 determinant, that is 2, 3, minus 1, minus 2. 2 into minus 2 is minus 4. Here in the formula minus is there. So here already one more minus. That minus minus become plus. 1 into 3 is 3. Now minus j cap into, so particular column and particular row leave it. 1, 3, 2, minus 2. Same determinant rule. 1 into minus 2 is minus 2. 2 into 3 is 6. In the formula it is minus 6. And the last term plus k cap into particular column, particular row, you leave it. You will get 1, 2, 2 minus 1. 1 into minus 1 is minus 1. Minus 2 into 2 is 4. So finally this become minus 4 plus 3, that is minus I cap. Minus 2 minus 6 is minus 8. Minus into minus plus 8 j cap. And here minus 1 minus 4. Minus 1 minus 4 minus 5. That is plus into minus minus 5 k cap. So this is the solution of A cross B. Now observe the students. Cross product of two vectors gives another vector. Okay, so I can conclude that dot product of two vector is scalar, whereas cross product of two vector is vector.